Good afternoon, one and all present here, respected teachers, honorable dignitaries, and all the attendees of the international conference. As we all know that the topic of today's international conference is future opportunities based upon cloud computing. So let's know a bit about what exactly is cloud computing. Cloud computing is the computing resources provision on demand over the internet. Resources can be servers, storage systems, data networks, software, and platform services. Cloud service providers distribute computing resources among different customers. Each of the customers receive the capacities or services required a pool, which is scaled if necessary. Financially, cloud computing is convenient for the consumer in that there are no capital costs for own equipment and premises for it, only operating. The service is paid upon use. For example, for the resources allocated, amount resources or for the used capacity for a certain period. The resources amount increases or decreases when the need arises. That is, there is no problem with equipment or service downtime. Clouds are used in almost all high-tech industries, in software development, in projects based on IoT, for big data analysis, etc. There are also more highly specialized tasks that are solved in cloud. For example, real-time speech processing using AI or artificial intelligence. So today, I, Sakshi Sinha, BCA 4th SEM, on the behalf of IMS Noida, would like to welcome all the dignitaries of this international conference. That is Ms. Niloshima Srivastava ma'am, lead SDE3 at DCI MCT C# Corner MVP. Mr. Nandadeep Nachan sir, O365 consultant, Microsoft MVP. Mr. Vishwanath Swami sir, principal software engineer, C# MVP. Ms. Smita Nachan ma'am, lead software engineer, Microsoft MVP, and Mr. Bhaskar Das sir, solution architect, inventionalist. I would also like to thank Dr. Manju Gupta ma'am, Dean Academics, SOIT, IMS Noida, and Dr. Rohit Kumar sir, HOD, SOIT, IMS Noida, for providing me the golden opportunity for speaking in front of renowned dignitaries in IT field. So here is the format to give you an idea of what to expect. This entire international conference is divided into two sessions. In the first sessions, the speakers are Ms. Niloshima Srivastava ma'am, Dr. Manju Gupta ma'am, Mr. Nandadeep Nachan sir, and Mr. Vishwanath Swami sir. And in the second session, there will be a panel discussion upon the topic future opportunities based upon cloud computing. And the speakers are Dr. Manju Gupta ma'am, Ms. Smita Nachan ma'am, Mr. Bhaskar Das sir, Mr. Nandadeep Nachan sir, Ms. Niloshima Srivastava ma'am, and Mr. Vishwanath Swami sir. At the end, we will have query session where the students can ask queries to the dignitaries. Now let's start with the first session of the international conference. So now I would like to introduce Dr. Manju Gupta ma'am. Dr. Manju Gupta is a Dean Academics at IMS Noida. She has delivered trainings on various IT technologies like Java development, digital marketing, basic and advanced Excel, project management, and data analytics to various clients like CDAC, Airways Infotech, Test Play, IMS Noida, and to many more national and international participants. She is offering performance-driven leadership and training experience in the areas of IT operations, business creation, team structuring and management, build strategic alliances, drive distribution, successfully managing P&L, competitive intelligence, project management skills, and process excellence. Her key expertise areas are academic or strategic planning, business analysis, operations and delivery, industry and relationship management, training and development, strong international and presentation skills, leadership abilities, and persuasive communication. Now, I would like to invite Dr. Manju Gupta ma'am to speak upon the topic. Welcome, ma'am.
Thank you, Sakshi. So on behalf of IMS Noida, I would really like to thank Ms. Niloshima Srivastava, Mr. Navdeep Nachan, Mr. Vishwanath Swami, Ms. Smita Nachan, and Mr. Bhaskar Das, who graciously, accepted the invitation, and we thought to discuss about this topic on cloud computing. So I'm sure this must be coming into the mind of the student what would be the future of cloud computing, because everybody is talking about cloud computing nowadays. So in recent year, there has been a lot of talk about cloud computing and cloud storage, like Microsoft Azure, Amazon Web Services, and Google Clouds. And there are also relative newcomers to space like DigitalOcean, Vultr, Lingot, Cloudways. So almost everything in the digital world is connected to the cloud in some way or the other way, unless it is specifically kept in local storage for security reasons. So as I generally see the tech giants and startup, they find new ways to organize, process, present the data in cloud computing, and which will become a more and more integral part of our life. So what would be the impact of cloud computing on future business strategies? I'm sure the speaker today, all these speakers would definitely enlighten us that how the future of cloud computing will take up to the students, and how students have to prepare themselves in terms of the cloud computings. And we can through around the concept like serverless clouds and decentralized cloud computing. But first, I think we should understand about the basics of this cloud computing, how this computing happens, and how the cloud computing is the practice of using a network of remote server hosted on the internet to store, manage, process data rather than a local server or personal computers. So that means business is a workspace, and the entire team can interact in regardless of where they are in the what I'm sure every student must be knowing that how this cloud computing concept is working. So it means that business can outsource their computing power instead of investing in the hardware, software, and staff to maintain it, as Sakshi has rightly said. And they have different services. We call it as SaaS, PaaS, AAS, and DAR, which come to dominate the markets. So on the hunt of these answer to those questions which students must be having in the mind, I have taken the views from the different industry experts ranging from founder to disruptive startups to executive of multinational corporation. So there are different views by the HP people, or maybe from IBM, or Microsoft, or different IT giants. They have their different opinions. So I'm sure this would be a very enlightening session today's to hear from the experts on this topic more and more about it. So this is as per my understanding that cloud would be the future. This is currently happening into and evolving into a very larger scale. So I really welcome and heartily welcome to the guest and panelists today onto this subject. We are discussing on a very apt topic, I can say. Thank you.
Thank you so much, ma'am. Now I would like to introduce Ms. Niloshima Srivastava, ma'am. Ms. Niloshima Srivastava is the lead SDE3 at DCI, Certified Cloud Architect, 5x Azure and 1x AWS, MCT, CSN, author and speaker in Microsoft Technology Stack, AI and DevOps. She is a technology enthusiast and a C Hash Corner MVP, 11 years of experience with Microsoft technologies for Windows or desktop-based application development, ability to transform ideas into working software with designing and implementing the core features. Worked with various SDLC methodologies, currently working on Agile or Scrum. She is a trainer, blogger, speaker, freelancer, consulting, and most importantly, learner, passionate about latest technologies like blockchain, Bitcoin, mobile, cloud, microservices, cognitive services, open for freelancing, training, and consulting. She has good interpersonal skills, logical aptitude, experience of client interaction, good exposure of OOPS design and enterprise pattern, UML, framework design, code review, project planning, and many more. Now I would like to invite Ms. Niloshima Srivastava, ma'am. Welcome, ma'am.
Thank you so much, Sakshi. Thank you so much for being here on a Saturday, on a weekend evening. So today we will be talking about the serverless paradigm on Azure. So this is the primary discussion we'll be having. But along with that, we will also just try and understand what was the situation before cloud, what happened when IaaS kicked in, what happened when, we moved ahead with SaaS and then SaaS, and then how we, how the whole how the whole game changed when we moved into serverless. So Sakshi has covered more or less what I do, but this is a glimpse of myself. So I'm basically working as a lead SD3, technical architect with DCI, Digital Control and Corporation. I have close to 12 years of experience with Microsoft technology stack, worked with various service-based and IT product-based organization. I have worked with big brands like Morgan Stanley, Philips, Pfizer, so to say, and a couple of startups as well. So these are my details. If you would like to reach out to me, buzz me in anytime. This is the agenda which we will cover in this half an hour session. We'll talk about what is serverless. We'll see the serverless services on Azure and how does it, integrate with Visual Studio and other services which are provided in whole Microsoft ecosystem. So let's get started. We used to have on-premises. So moving to cloud is more or less how to structure, how to secure your data. So earlier, everything used to be on premises where we as an organization, we as a team used to cater everything, and then infrastructure as a service kicks in, where you get your servers and storage and security. So look this as an picture where you are minimizing your responsibility by not managing the servers, by not managing the storage and the security paradigm which is related to this whole infrastructure as a service. Then kicks in the PaaS. With the PaaS, you get, along with IaaS concepts like server, storage, and security, you don't have to manage your operating system and software, and your machines are development ready. So you get development tools so that you can leverage them, which will basically your whole development time will reduce because you're not worrying about the operating system, you're not worrying about the development tools, your machines are up and running, and you can start spending on the actual business for which you have been hired for. Then kicks in the serverless. So with the serverless, what you get with the serverless, there are certain apps, there are certain services which basically you leverage on any cloud provider, so to say. You'll get full abstraction of services. You have instant and event-driven scalability, and it is basically pay per use. So you only pay for what you use, and the billing is typically calculated on the number of function calls, your code execution time, and the memory which you have used. Before cloud, these many questions we used to ask. Do I need a UPS? Who has access to my physical server? What is the right size of server in my what is the right size of server which I'm supposed to use? Who will monitor my application? What happens if we get to in any server failure, hardware failure situation? Do I need a secondary remote condition? So all of these services will basically be parked to the cloud provider, and they are going to take responsibility on your behalf to give you answer for these questions. There are certain aspects of cloud where you can automatically scale in, scale out, scale up, and scale down. We call it horizontal and vertical scaling, so to say. Along with that, they give you the flexibility of backing up your data in multiple locations, in multiple regions, so that if if anything happens to maybe one of their data centers, your data is, you still have the backup so that they can, provide that whole data to you if you have selected to do so. Then, infrastructure as a service kicks in. So infrastructure as a service answers these many questions for you. What is the right size of servers for my business needs? How can I increase server utilization? How many servers do I need? Who will monitor my app? Which operating system should I use? All of this has been catered by the cloud provider. In this case, today we'll be talking about Azure, but everything, each and every cloud provider, they basically answer these questions. The security aspects like, updating and upgrading your operating system, the patching of the security updates, backup of your server, all of these are managed by the cloud providers. Then, platform as a service kicked in, and platform as a service basically, helped you find answer of these questions. I mean, on do I, how would I go ahead and scale my application? How do I increase my server utilization? So with platform as a service, you get an opportunity where you are not managing with operating, when you were operating with infrastructure as a service, you anyways were not managing the servers, the network. But with when platform as a service kicks in, you are not managing the operating systems and the development related tools. So let's say if I need if I need a machine on which I would want SQL Server pre-installed so that I can leverage it, I can go ahead with PaaS instance. And then, the fancy concept of serverless comes in. This doesn't mean that you do not have servers. It basically means that I'm not going to, manage the server. I'm not going to, I don't want to go ahead in the, in the headache of managing your servers for efficiency, for flexibility, because you can easily pivot, means for flexibility. You can easily do your experiments. You can scale at your own pace. You don't have to be on the farm, on day one for if you are basically working with enterprise level applications. And serverless is basically a natural fit for your microservice. So you can solve your business problem, which are not technology related, to undifferentiated heavy lifting. So you are not doing, you are not thinking of designing your actual, or let me say it other way around. You will mostly be thinking of your, about your, the way which you, with the help of why I'm solving this business. This is the business I would like to solve. I'm not going ahead into the, into the facade of creating the servers, managing the network, the storage, the data, the backup. Everything will be managed by Azure. Okay, so what is serverless? With serverless, you get the full abstraction of servers. So by full abstraction of servers, what I mean is that developer can just focus on their code. There are no distraction around server management, the capacity planning or availability. Your application components, they react to events and triggers in near real time with virtually unlimited scalability. You can leverage compute resources as you need. And definitely you are, only paying for what you use. Your billing is more or less calculated on the number of the function calls which you are sort of leveraging by kicking in your code piece. You also, your billing also, does move around your code execution time and the memory which you are using. So these many things you won't manage, you won't do, and you'll pay for what you are only using. There are different paying, plans available for payment. You can go ahead with consumption-based plan. You can go ahead with premium plan as and when you are, moving ahead with your business requirements. Let's just discuss what are the benefits. The first benefit, which basically is the major one, is that of focus. You solve the business problem. You are not solving that technology problem, where you are sort of managing the whole infrastructure behind your application. You become efficient. By efficient, I mean that you will have shorter time to market. If you have an idea, the whole transitioning time from developing it and deploying it and then to market will be less as compared to any server-driven architecture. You have, your fixed cost converted to variable cost. So let's say if you have, maybe let's say you are spawning a virtual machine to deploy your application, and maybe you are using it for just a mobile application backend. So that earlier, even with the IaaS and the PaaS, your costs are predetermined. Okay, you have to spend maybe $100 for that level of capacity of your server. And believe me, I have been working on serverless from last, I guess, 2 years or now. What we used to do, the cost on when we were using the server-based architecture, we used to pay close to $1,000, and now we are running close to 10 environment of the same application, and the cost has been reduced to what, I guess, $200, so to say. And this also offers, the service stability. You will get better development, you'll get better testing management, and the waste is very less. It also gives you a benefit of flexibility. So your starting experience is simplified. And since your pivoting is easy, which gives you more flexibility, your experimentation becomes easier, and you can scale it at your own pace. You don't have to think of everything from the day one, because rest of the thing which is running in the background has been taken care by your cloud provider. Now, if you guys have heard of Docker, so serverless, or maybe any serverless paradigm, be it function or Lambda, they are nothing but a glorified Docker container. You kick in your code, and as and when that piece of code is triggered via some external dependency, a Docker container, which basically has your infrastructure, because you said that I would like to run, maybe you are working on a Python application, so that will spawn that Docker, and your application will start running. So that's how these serverless services, they serve you. And like I said, they are the natural fit for your microservice application. So FAS is basically function as a service. So function as a service programming model is basically used to achieve true serverless compute. FAS is a serverless way to execute your modular piece of code on the edge, and it lets the developer write and update the piece of code on the fly, which can be executed in response to an event, maybe such as something like user is clicking any button on your web application. So I want to talk about this as a platform, not an individual service. So it's a group of services. a collection of fully managed services that come together and allow you to build serverless application. When we talk about serverless, the first thing that obviously comes to the mind is fast only, because it gives basically, the ability to execute your custom code on demand without having to worry about where the code is executing and how it would scale if the demand goes up. So functions are nothing but Azure's, we call them Azure functions. So functions are Azure's serverless, services. So functions are single purpose. They are reusable piece of code that process an input and return a result. So they share a single responsibility. Another, property of functions is basically because they are short-lived. So functions don't stick around when when they have finished their execution. They immediately free up the resources for further execution. They don't hold any persistent state. That means that they are stateless, and they don't rely on the state of any other process. So I chip in a code, it gets executed, and since work has finished, we are good to go. We don't want to bother about that, how that function has been spawned, how it is being managed, the on-demand scalability. And a function is an independent execution unit, which basically does not hold any state. Along with that, functions respond to predefined events, and they are instantly replicated as many times as needed. So if you have chosen for maybe auto scaling, and you have 100 hits hitting on your your Azure function, or maybe your serverless architecture, they have the capability of scaling up on demand. So you don't have to bother on how your function is driven. So we already saw how, we know that function provide an experience of responding to the events through the code that in turn process your input or maybe your data that could be coming from any number of services, or that could be heading to any number of services. Some of the key highlights that function provide, or any serverless service provide, is ability to build, test, debug your function code locally on your own machine before your code is even deployed to the cloud. So this is a massive productivity benefit while building cloud application, and and something that Azure provides through rich integration with world-class developer tool like Visual Studio. The second unique feature is that it basically works on pub/sub architecture. You have events and bindings that make it super easy to set up your event-driven architecture and simplifying your communication with data sources. Third, Azure supports number of programming languages. So it supports C#, but you can also use Node.js, F#, Python, and even Bash, so that you can pick the language of your choice to write serverless function with. Lastly, the functions, they support concepts such as continuous development, continuous integration, which make it super easy to integrate them with your existing DevOps pipeline. So in short, function, basically in short, function is a unit of work. They are executed, they start and finish, they have triggers, and they also have input and outputs, which we call in this whole ecosystem as binding. So this is your Azure functions, which these are the properties which we have discussed about it. You have you can boost your productivity. You can choose variety of, from the variety of your programming languages.
Now I would like to introduce Mr. Nandadeep Nachan sir. Nandadeep Nachan sir joined the Microsoft TechNet Wiki on Facebook group about 10 months ago and already became one of the top active members. He participates in the community's activities in the field of Office 365, SharePoint, DevOps, and Teams. He helps people in the MSDN forums and take part in discussions which will shape the future of the communities. He already posted 51 new articles, which won 12 gold medals, 9 silver medals, and 8 bronze medals. He is a result-oriented technology architect with experience in Microsoft technologies, especially with SharePoint, Office 365, and MS Azure. Experienced in design, implementation, configuration, and maintenance of several large projects. He has done various certifications, including Microsoft Azure AI Fundamentals, AI 900, Microsoft Azure Data Fundamentals, DP 900, Microsoft Security Operations Analyst, and Associate SC 200, Microsoft DevOps Engineer Expert AZ 400, and Microsoft Mobile and Security, and many more. Now I would like to invite Mr. Nandadeep Nachan sir to speak upon the topic. Welcome, sir.
Hello, thank you. Thank you very much for that introduction. I hope you can hear me loud and clear. Okay.
Yes, sir.
Yes, sir.
Yeah, thank you. Let me share my screen. Just a moment. Okay, please confirm if you can
Yes,
see
sir.
my
It
screen.
is visible. It is visible.
Okay, all right, great. All right, so hello all, good afternoon, and thank you for being here for this Cloud Tech student conference. It's nice to see you all attentive here for this entire session. So in this particular session, I'm going to talk about introduction to Azure functions. And just a moment. Okay, so the agenda for this session is that we will have overview of Azure functions. What is mean by Azure functions? What is the significance of Azure functions? Why and where we should use Azure function? Then what are the features which are provided by the Azure functions? And then what are the common scenarios in which we should use those Azure functions? Then again, what are the best practices? What is the pricing associated with that? And then we will have a quick demo. I know that Swami sir are here to give you various demos onto the Azure function, but I know after lots of talking, almost 20 minutes, I should show you some demo, at least how the Azure function looks like. Okay. All right. So I think that will get you excited for this session. So before I start the session, quick introduction of myself. So my name is Nandadeep Nachan. I'm Microsoft 365 MVP and Microsoft certified trainer, C# Corner MVP. I'm based out of Pune and author of a couple of books on SharePoint framework and SharePoint hybrid. And here are a few social handles of Twitter and LinkedIn. If in case you want to get in touch with me for topics related to Azure, Microsoft 365 or any of the other discussion, please feel free. Okay, so with that, let's start with the actual discussion. So before I directly jump into the Azure function, directly start talking about the Azure functions, I want to just take a step back and probably we will start our discussion with serverless computing. So let's say like what is mean by the serverless computing, which we feel like whenever we talk it about the serverless computing, does it mean that we don't have any servers? So yeah, means we cannot say that there are no servers as such, because until we have the server, we won't be able to run our code. So it doesn't mean that we don't have the servers, but just that servers are there somewhere, but we don't have to think of those servers. We just have to think of our code, write our code, get it executed, and we are done. So we don't have to think about servers. Okay, but just to make sure, or just to make it clear, servers are there hidden in the background where our code is running. So the serverless computing enables developers to build applications faster by eliminating the need for them to manage the infrastructure. So infrastructure, that means the server, the hardware, and all the other things. So with the serverless applications, the cloud service provider automatically provisions, scales, and manages the infrastructure required to run the code. So in our case, when we will try to create the Azure functions, we don't have to worry about where that code is hosted, which server is running on that. We can just solely concentrate on our code, get our code executed, and then from there it will start working. So in the understanding of the definition of serverless computing, it is important to note that servers are still running the code. The serverless name comes from the fact that the tasks associated with infrastructure provisioning and management are invisible to the developer, and they will be taken care by the provider. That means Microsoft in this case. So this approach enables developers to increase their focus on business logic and deliver more value to the core of the business. So we don't have to worry about the servers. Only thing, we can concentrate on our code and get our work done very much faster. So this serverless computing helps team increase their productivity, and then it brings products to market faster, and then it allows organizations to better optimize the resources and stay focused on the innovation part. So let's see then what are the benefits of this serverless computing. So there are various benefits of serverless computing, not just this slide is the only benefits are serverless computing, but yes, I just wanted to present you the major benefits of serverless computing. So let's talk about the first benefit that we have. So the first benefit is no infrastructure management. So again, the serverless, that means we don't have any infrastructure to manage. So using fully managed service enables developer to avoid administrative tasks and focus on the core business logic. With the serverless platform, you simply deploy your code, develop your code, and it runs with the high availability. So we don't have to think about the infrastructure, maybe the networking, the server itself, the processor, and all those things. We don't have to think of that. Only thing that we can concentrate is on our code. The second benefit is the dynamic scalability. So scalable, that means we will be able to scale in and scale out. That means not at all the times we need some kind of a functionality at its fullest threshold. Sometimes there are less demands. In that case, we can use low resources. In some conditions, there will be higher demand. In that case, we should scale up and then try to match up that demand. So with the serverless computing, the infrastructure dynamically scales up and down within seconds to match the demands of any workload. So for example, if there is a low workload, it can scale down, and then you don't have to pay that much to the provider, that means to the Microsoft. And in the case wherein there is a higher demand for your workload, in that case, it will be automatically scaled up, and then it will provide all the responses to your scaled up request. Okay, but again, there will be increased cost to this. So at least these are the benefits. And then the other benefit is that with this serverless computing, it is very much faster to market. So we have very much faster time to market. Serverless applications reduce the operations dependencies on each development lifecycle, and it increases development teams' agility to deliver more functionality in lesser time. Because now that we don't have to worry about server, we don't have to worry about the patching. Only thing to concentrate is on your code. So you can just focus on your code, and then you can deliver that code faster to the market, because all of the other dependencies are gone now. The fourth benefit that we have of the serverless computing is it is more efficient use of resources, because shifting the serverless technologies help organizations to reduce total cost of the ownership, and then reallocate the resources to accelerate the pace of innovation. So for example, you have any of those servers running. In that case, you will have to take care of each of the requests which is coming to that server. But now that you can efficiently use the resources because you don't have to worry about the server, the only focus will be on the code itself. So these are the various benefits of using serverless computing. Again, there are many more of this, but at least these four are the major one because of which the serverless computing is very much popular. Okay, so now that let's talk about this Azure Functions, which is a serverless event-driven experience. So Azure Function, by its name, again, it says that it is a serverless solution which allows you to write less code, maintain less infrastructure, and then save on the cost. So instead of worrying about deploying and maintaining the servers, the cloud infrastructure providers provides all the up-to-date resources needed to keep your applications running. Okay, so we often build system to react to a series of critical events, whether you are building a web API, responding to the database changes, or processing any kind of an IoT data streams, or even managing the message queues. Even application needs a way to run some code as the event occurs. So to meet all these needs, the Azure Function provides compute on demand in two kind of significant ways. Okay, so firstly, that Azure Function allows you to implement your system's logic into readily available block of code. So you can have create those simple block of codes which can be run as a part of Azure Functions, and these code blocks are called as a functions. So Azure Functions can have various function inside that, and then different functions can run anytime you need to respond to those critical events. Secondly, that as a request increase, Azure Functions meet the demand with as many resources and functions instances as necessary, but only while it is needed. As the request fall, any extra resources and application instances, they will be dropped automatically. Okay, so these are the two advantages that we have of Azure Functions. Then again, we do have a code which is running as a part of Azure Function. We are responding to various events. We are playing around with various of data, and if you combine these both, then we have these Azure Functions. Okay, so this Azure Functions is a serverless compute option. It uses event-driven model where a piece of code, that means a function, is invoked by a trigger. So this is the simple meaning of this diagram that I have. So in short, providing compute resources on demand is the essence of serverless computing in Azure Functions. Okay, so let's see what is the architecture of this Azure Function. I know that this sounds very complicated with the architecture and all those terms, but let's not make it too much complicated. Okay, so only thing that we need to know here is that Azure Functions are built on top of Azure App Service and Web Job SDKs. So there are many different definitions for serverless architecture. But in fact, servers are still very much required. You just don't have to think about them. Okay, so fundamentally, serverless architecture is the next evolution of cloud services built on top of PaaS, that means platform as a service, abstracting away your virtual machines, application frameworks, and the external dependencies via binding, so that developers can only simply focus on the code to implement the business logic. Okay, so maybe let's walk through this diagram very quickly. So now that we have a code that we want to run, and again, code cannot be just run individually, but again, there can be some kind of a configuration which could take place on that code. So for example, we have some configurations like the database string or anything, not exactly related to Azure Functions, but at least a few kind of configurations that we will have, which we have to read through our code and then process further. So that means we do have a code, we do have some kind of configurations which will be needed while running of that code. And then again, this particular code can be written in various languages, including C#, Node.js, F#, PHP. So Azure Functions supports variety of languages. So those includes this even Node.js and even Windows PowerShell. So runtimes and dependencies are handled by this platform. So platform handles all those kind of dependencies. Then using these Azure Functions as a serverless compute component of serverless architecture provides various key benefits, like it reduces the time to the market, it lowers the total cost of your ownership, and then you can just pay per your execution. Okay, so the number of calls that you are making to that Azure function, only for those calls you will have to pay, not for the entire thing. Okay, so at least this is the basic architecture, that how the Azure functions are placed. So then the features which are provided by Azure functions. So as I said, there is a good support for Azure functions from the programming language capabilities. So for the programming languages, you can write this code or write these functions in a C# or using Node.js, using a JavaScript, Python, F# or PHP. So it is not kind of limited to set of developers. The background from which you are coming, you can utilize that to create your own Azure functions. And again, it is not just limited to the programming languages. Even for example, if you are some kind of an admin who mostly writes the scripting languages using PowerShell, batch processing, as well as Bash, in that case, even you can use those scripting languages to write your Azure functions. So it is kind of an inclusive of both the areas of programming languages as well as the scripting languages. And then again, when we write any kind of a program, we do have some kind of dependencies. So dependencies, that means we do write our code, but again, that code may be dependent on any of the third parties. So let's say any of the package which is doing the mathematical calculation, or any of the package which is doing the date calculation. So for example, if you have heard of Moment.js, so Moment.js is again kind of one package which help you to adjust the formatting of your dates. Okay, so because worldwide the date is being organized in various formats. So as an Indian standard, we do it as a DD/MM/YYYY, but for the others, it may be month first, date later, and year later on. So this kind of formatting being done by a few kind of packages. And then all these packages are available under NPM, which is kind of a node package manager, or it could be available for NuGet. So the basic difference between these NPM and NuGet is that NPM are mostly used by the open source kind of languages, for example, JavaScript, TypeScript, and then NuGet is majorly for the .NET kind of thing. So let's say, for example, if you want to download the dependencies of the packages for your .NET, in that case, it will be a NuGet. Or for example, if you want to download the dependency of any of the third-party packages for your TypeScript or JavaScript-based code, in that case, it will be a NPM. So this Azure function do support for those kind of dependency. If you have any of the dependency on the third-party package, even those can be downloaded by Azure functions, and those can be invoked from the Azure functions. Okay. The next thing is that even it can execute any of the exe. So exe are kind of an executable code. So from the Azure functions, we can also invoke the exe and get the output. At the same time, even we can call any of the DLLs, so that dynamically linked libraries. The only difference between exe and DLL is that exe is a self-executable. It can execute itself, and then it can run the code. DLLs are not kind of self-executables. Those has to be invoked from any of the other callable system. But from the Azure functions, you can call both exe as well as DLLs, and then you can run your code. Because what happens is that whenever we write our code, it's not at all necessary that we should write all our code on our own. We can take help of the other packages available, other DLLs or other EXEs which are available as a community edition, or even as a part of Microsoft or any of the third-party providers. So Azure Function gives you the support for all of these approaches, that you can have your dependencies done through NPM or NuGet. Even you can execute your EXEs, or even you can call into your DLLs. So it also supports the triggers. That means it is a way to start your execution from where your code will start executing. For example, some event has happened, and on that particular event, we need to start executing our Azure function. So we will see in a moment like what those triggers could be. And then again, it do support binding. So that means it is again a way to simplify code for input and output of data. So you have a predefined input, you have some kind of a predefined output, and then the Azure function can be a binding between these two. So these are the various good features for which Azure functions can be used. The scenarios in which Azure functions can be used are very much, again, those are very much beyond the table that you can see on this particular slide. So the examples in which, or the scenarios in which Azure functions are mostly used, for example, if you want to build your own web API, so that means it will be some kind of an endpoint for your web application, and then you want to use the HTTP trigger to call those. So for that purpose, you can build the Azure functions. And then, for example, if you want to process the file uploads, and so in that case, you want to run the code when the file is uploaded or changed in some kind of an blob storage. So blob storage is again kind of an storage available from Microsoft Azure, wherein you can store or upload your documents or files. Thirdly, that, for example, if you want to build your own serverless workflows, even in that case, durable functions can be used. So durable functions, I just want to touch base upon this topic as well. So we saw that functions are stateless, they don't maintain any state, but at least these durable functions will help you to maintain that particular state. Okay, so state, that means let's say we have executed the code, and now that we have gone away from that particular code, and again when we will come back to that particular code, it will still maintain that particular state from where we can continue executing that code further. Okay. Fourthly, that we can respond to any of the databases change. So for example, if there is any kind of an document is being created or updated into the Cosmos DB. Cosmos DB is again kind of a non-relational database in the Azure, wherein you can store your I will not say document, but at least the information in the form of a JSON format. So even in that cases, Azure functions can be used. The very much famous scenario of Azure function is the scheduled task. So scheduled task, that means it is kind of a set of code which can run as at a scheduled interval. So let's say, for example, at 9 a.m. every day, we want to run particular code and want to check the active users in our organization. So this is one kind of an example of scheduled task. So the code will run at a specified interval, and then it will carry out the operations on the system. So for building those scheduled tasks, also we use the Azure functions. And then again, for example, if you want to create any reliable message queuing system, in that case, even Azure functions can be used. And again, it is again very much famous for the IoT data streams. So IoT devices are kind of devices who create various events based on the events those are being triggered by that device itself. So for example, if you are using the IoT devices for any kind of a temperature checking, in that case, let's say the temperature goes beyond 25 degrees Celsius, it will give you one kind of an alarm or one kind of an event, and those events can be processed from Azure Functions. So let's say if uh, if the temperature goes beyond 25 degrees Celsius, so you want to send out the custom notification to someone, those kind of scenarios can be built with Azure Functions. And then again, for example, if you want to process any kind of real-time data, Azure Functions can be used there also. Real-time data, that means as and when the event is happening, we want to process it very quickly and then take it to the output. So even for those kind of scenarios, these Azure Functions are very much used. Okay. So then what are the best practices when we are using this Azure function? So firstly, that Azure function, each Azure function just do one thing. So the Azure function should be a single purpose in nature. So think of them as a short, concise statement rather than very compound statement. So don't have multiple capabilities being done into one Azure function. So let your one one thing should be handled by one Azure function. Second thing is that Azure function should be idempotent. So again, all the operations are idempotent in nature. So this means that the resulting state of the system from a call to the API endpoint will be unchanged if it is called from the subsequent times with the same parameters. So I will take a very simple example here. When we enter into an elevator or a lift, in that case, let's say I want to go to the floor number 5. So what I will do is I will just press a button of 5. Okay, so because I want to go to the floor number 5. Let's say another person enters into the elevator at floor number 2. Even he wants to go at floor number 5. Even though the number or the floor 5 button is pressed, you will again go there and press 5. Okay, so that doesn't mean that lift will go to floor number 5 for multiple times. So it will just go to floor number 5, and then we both can be departed from that particular lift. So this is mean by idempotent. Okay, then again, thirdly, that all of the Azure function should be short executions. So that means the execution time should be very brief. The goal should be to retrieve input, perform the desired operation, and get the results into the downstream consumers. For the long-running processes, you might consider Azure Web Jobs or even hosting the services in Azure Service Fabric and all those things. But at least Azure function should be very short-lived. For that, Azure function should be async and it should avoid any kind of blocking. So that means async, that means, for example, we are calling any kind of an functionality, and if that functionality is taking too much of time to process the input and give us the output, in that case, we should not keep the other thread which has called into this particular thread waiting. So the main thread, it will continue working on its own, and the other thread will go process that request, and then it will again come back and join the main thread, and then from there the execution can start. Fifth is that we should have all the logs ready for our Azure function, because let's say the Azure functions are working very smoothly in our case, but it might happen that in some cases we might see some kind of failures into the Azure functions. So we need to see like where those failures are. We need to identify the potential cause of that particular errors. So for that purpose, logs are very much important. So just make sure that you do the sufficient logging. I will not say verbose logging. That means everything that we do for the Azure function should be logged, but at least have some kind of an definite logging done into the Azure function. So if in case something fails, we should be able to find out the reason, or at least come to the conclusion why it is failing. Okay. Okay. So then from the pricing type of the functionality, so at least when the okay, before that, at least there are 3 type of pricing plans which comes with Azure functions. So with the consumption plan, you can only pay while your functions are running, while the premium and app service plans offer features for specialized needs. Okay, so the consumption plans only pay for the time that your code runs, But with the premium plan, at least even any additional instances you use, or even the as you scale your app in or out, those kind of thing can be done with the premium plan. And again, there is something called as the app service plan, which help you to run your functions just like your web apps. Okay, so don't think too much about onto this pricing, but at least there is a pricing involved with the Azure functions. Okay, so at least these are the three type of functions that we have. So now that I know that I have done too much of talking about this Azure function, I just want to quickly show you how these Azure functions are, from where they can be created. I know this Swami sir will take it into the various demos, but I just want to quickly cover that part. Oh, sorry. All right. So for that, the first thing that we need to do is navigate to this portal.azure.com, which is the landing page for your Azure portal. From here, you can just click on create a resource, and there are various categories under which all these Azure resources are categorized. So here we have compute. So under the compute, we do have function app, which is our Azure functions. So here we have a link for docs, which will take you to the docs.microsoft.com for extensive documentation on function app. Once you click on create, it will take you to the wizard from where you will be able to create the function app. So from here, you can select your subscription. Then you can create your resource group, or if you want, you can create or use existing. So I will just create one resource group called as RG resource group and the Cloud Tech student conference. And then we can just have one function name for this. I will just call it as a AZ function Cloud Tech student conference. And then we do have two options here, code and the Docker container. We will keep it simple. We will just go ahead with the code. In the runtime stack, we do have various options to which this particular function app can be developed upon. So we do have a .NET, Node.js, Java, Python, various options. So we will select .NET here. Again, in the .NET, we do have various versions that we can select from. And then the region where we want to host this particular function app. The next tab is that we have a hosting, wherein we can create a storage account. So at least this will give you a default name for that particular storage account. So why do we need the storage account is that all of the code that we are running will be stored into this particular storage account. Secondly, we will need the operating system. It could be a Linux or Windows. So I will select Windows here. And this is the pricing plan, which we were just discussed in the last slide. So we'll go on the consumption serverless plan. Then in the monitoring, we can create the Azure Application Insights. So Application Insights are nothing but it will take the logs of all of your execution of function apps. So if in case something goes wrong, you can check out those logs. Just to make it simple, I will select no, because it will take some time, and I just want to avoid that. Tagging is just that for any kind of an tagging purpose. Like, let's say, for example, for HR department, you're creating this function app. In that case, in the name, you can say department. In the value, you can specify HR, so that you will be able to come to know for which department, how many functions tab do we have, and all those things. In the next step, we can just click on review and create. So it will review all of the information that we have set in. It will validate, or this wizard will validate all that information. If there is any error, it will show that error. Fortunately, there is no error, and we can click on create. So at least this particular resource will take maybe 1 or 2 minutes to get started, because there are many things that it creates in the background. So first one is the storage account that we have seen. We have disabled the application insights, but at least it will create that resource group. Then it will create the Azure function itself. Then it will also create the storage account. So now that from here, you can see that it has started creating all those resources one by one. So we have one first type of resource being created as the server farms. Second one, it is right now creating is the storage account, where we can store our code. All of the status can be seen from here. If you want to go into the details of where it is created, how it is created, you can click on operation details to see those details. But at least this will show this deployment is in progress. And here is a refresh button if you want to see on a regular basis what is the status of your deployment. It is still being deployed. We have this shield storage account being created. We might have to wait for 1 or 2 minutes here. So what we will do here is we will not write any kind of a custom code when this Azure function is created, but we will just navigate through the code which is being created by this Azure function. And then we will just run through that code. We will see how we will be able to run that code, and then we will take it to the next level. Okay, so now from here, you can see that at least this deployment is complete. Once we click on go to resource, it will take us to this Azure function that we have created. And here, as I said, in the Azure function, we can have various functions. So for that purpose, I will click on these functions. And here we can create and manage all of the functions that we want. So I will just click on add to add a new function inside this Azure functions. And here we do have a template to select from. So we have various templates like HTTP trigger, the Azure bus queue, and all those things. So for a simplicity, we will go ahead with this HTTP trigger. Okay, I think I did not get selected. It is still loading, just a moment. So once it is selected, this add button should be enabled for us. And from here, we should be able to select that. It is taking some time because of my internet connection. So let me try it one more time, add function. From here, we will select this template, and okay, now this add button is enabled. Let me click add. So this one will be a very simple function which can be triggered from HTTP endpoint. Okay, so once that function is created, from here we will be able to see that function. And once you come to this code plus test, from here we will be able to write a code inside this Azure function, as well as we'll be able to test that code. So this is the basic code that we have. These are some kind of using statements for the .NET. And then this particular function has got one method, which is static asynchronous method, because we saw that Azure function should be asynchronous. So we have one method here called as run, which accepts two parameters. First one is the HTTP request, and second one is the logger, which we will use for the logging. So first, the logging can be done with log.log information. You can send the message which can be logged. And then again, we have this request, HTTP request. So from here, what we are trying to do is we just want to get the query string parameter with the name of name. And then what we will do is we will compose that request body from here. And then if we have some kind of a value inside this name, we will print out that value. If no, then we will keep it blank. Okay. So very simple implementation of this Azure function. If in case you want to test it out, click on this test or run. So in the body, we have name specified as Azure. Once you click on run, it will run this particular Azure function, and then it will say hello to this particular name. So it should not take much time, but okay. So now that we have a hello to Azure, and the trigger has got successfully executed. Now that since this is the local testing or running, if you want to use this in your day-to-day job, in that case, you can click on this get function URL, copy this particular URL, and this URL can be taken to your browser, and from where it can be also invoked. So now that since we did not pass anything, it is saying that the trigger function executed successfully, pass a name in the query string. So let's say I will pass a name in the query string by and name equal to Nandadeep. What it will do is now that it will be able to get that query string parameter, and then the function got triggered and it was able to run, identify that parameter and process that. So these are the simple happenings which is for Azure function. And again, at the bottom, you can see even it is logging few of the things. Okay, so even the logging is very much important. So I just wanted to keep it very simple after my continuous talking of 20 minutes, because until and unless I show you the demo, you won't be able to realize what is meant by Azure functions. But I know that now the Swami sir will take it to the next level and show you some cool demos. But yeah, miss, at least if you want to read more about the Azure functions, here are a few of the good references by which you can read more on Azure function documentation, or even the Azure function pricing. So with that, thank you very much for having me here. Thank you very much for listening to this session, and I will hand it over it back.
Thank you so much, sir, for enlightening us with your great knowledge. Now, I would like to introduce Mr. Vishwanath Swamy, sir. Mr. Vishwanath Swamy is the Principal Software Engineer, C# Corner MVP. As DevOps Technical Lead, executes Scrum ceremonies, sprint planning, capacity planning, user story grooming, story points estimation, sprint demo, and retrospective, narrative document, code review, and automated testing. As part of microservices, API gateway and backend service is deployed in Service Fabric cluster. Also deployed another set of microservices, API gateway and backend service inside Docker or Kubernetes cluster. Well organized with a track record that demonstrates self-motivation, creativity, initiative to achieve both personal and corporate goals while managing clients across diverse categories. Recipient of 10 awards, gained 3 years of on-site experience working for US client. Now I would like to invite Mr. Vishwanath Swamy, sir. Welcome, sir.
Hey, thank you so much, Shakshi. Hey guys, this is Vishwanath Swamy. Let me share my screen.
Not visible, sir.
Yeah, I'm doing it right away.
Yes, sir. It is visible, sir.
Dr. Rohit, is that? Okay,
Yes,
cool,
sir.
thanks.
It is.
Hey guys, good afternoon. Thanks for joining. And this is where we will be having our entire source code. I'm going to create a new folder. That folder name will be 2905-2020 Cloud Tech Student Conference. There will be a new folder here. I will be pasting it here. We should have some chart. Don't we have the chart option? You want to paste something? I am not sure. Okay, I'll give it to Atul sir, so you can forward it to you guys. Okay, the entire source code will be available over here. Will it allow to do a message chat somewhere in this one? Zoom, because I'm using Zoom for the first time. I don't know.
No, sir.
Okay, that should be fine. No problem. We'll start with some. What's that? Okay, so we'll start with this demos. So first thing what we will do is we'll do some demos. So we'll create, we'll see within next 30 to 40 minutes what all the things which we can do. We'll try to do one demo with C#, one demo with Node.js, and see how many types of bindings or triggers we can target within this time. So let's start doing it. It will be like do and learn. Okay. So at this point of it doesn't have any application. I'm able. Okay. There's some background noise. Okay. So what I just created is this Azure Function app, and the runtime stack. What I have taken is the Node.js. So before this, in the previous demo, we have chosen the .NET Core as a runtime, and here the runtime is Node.js. Okay, so we'll start with some Azure functions, and before that, let me go here and let's understand this storage. What is there inside this storage? We can use this Explorer. We can use this storage Explorer over here, and or I can come in here. This is in preview, so you can see that the Azure Web Jobs host and Web Jobs secrets. So these containers which are going to host the Azure functions. Whatever we have the Azure functions, that will be stored. So as of now, we don't have any Azure functions. So we'll come back and revisit that place once we create one or two Azure functions, right? So let's go ahead and create Azure function, which we call it as a array operations. So I'll come in here, click on add, and folks here is not talking. Please mute your phone, and we'll use it as a HTTP trigger. And then what we will do is we can change the name over here at the bottom. We need to scroll to the bottom and then click on add. So once we click on add, it will go and create this Azure function, and we can come in over here in this block. In this drop down, you have Azure function and index.js. So if you go to this Azure function, so this is the one which says that it has got all the bindings. It says that, okay, the binding type is HTTP trigger and the direction is in. That means someone is going to hit this from some application or the command line curl or any HTTP tool or Postman. You can use multiple things, right? And right now we are allowing methods get and post methods. These are HTTP methods which we are allowing. That means we are telling that if you want, you can come and hit us through get, or you can come and hit us through post. And the output direction, what we are telling is we are going to send the output for HTTP. And here in this index.json is pretty simple, which is going and checking for a variable which is this name, either in the query string or in the request body. So we'll see that how to do those two. See this here, and if I send this, that means it is coming and hitting this one. How do we know that whether the function was successfully called and what was written? You need to come to the monitor, and in the monitor it will show that how many times it has executed. Just now we sent it, so it will take some time. So it says that HTTP trigger has executed successfully. Please pass the name as a query string. So I can come in here and I can type name equal to no name, and I send this again. So what's this is expecting the lowercase name. It's case sensitive, so we should be a little careful. Let me check that. Okay, the name is lowercase, so I have sent it in the uppercase. Expecting this lowercase name, it says that hello, no name. So that means it is coming and hitting it here. So we can come back to monitor, and you can check the logs. As and when whatever we are executing, it will spit the logs over here. So if at all there is any exceptions or anything, we can come and check here. So let me create a duplicate of this so that we can move it a bit faster. So let me hit this couple times. So this is we are coming through get method. So you see this, all the logs, as and when you'll get a running logs, as and when someone is hitting this method, you can come and track what is happening in this. And the other way I can do is I can switch it to post and come to this and raw and select this application JSON, and inside the body we need to send name Matthew Phillips, and I click on post. So you see that it has went ahead and took this parameter and executed it. So should be able to see one more point. I'm just trying to function as requested. Let me go to this. I'm sorry. Let me come to this monitor. Let's see that it takes some time, 10 to 15 minutes time. We'll see if it is flushing. See this, it is flushing out those things, and it says that we can get into this. It has been organized, so again go and get into see the latest one, and you can see that it executed, and it is giving all this information. As and when we write more logs, we'll be able to see all those logs here. You can come into this section also. Instead of the invocation section, you can come to this log section also, where you can go and get the details of these logs. So what happened with this. So now it's the right time for us to go back to check the storage. So we just created an Azure function, and we added a function app, and we added Azure function, but it has created application insights and storage account. So we don't know why it is creating all these things. So let's go and see that. What is that? Let me go here in this account. Let me get into the storage, and let's go to the storage explorer, and here you can see this. We have the file share and nothing in this queues and tables, and you can see if you come in here, the Azure portal AZ func. So that's the name which we have given to our Azure function. And if you get into this site, you see that www root. When you go into that, see this, the Azure function and the host.json. So now we know that when we are creating the Azure function app and Azure function, why it is creating the storage account. So it is using all the files and all the artifacts here. So I can get into this array operations. See this, you see the same index.js as well as the function. So that's one of the reason it needs the storage. And here you can go and check these whatever is the secrets, web job secrets and everything. See, you have that host.json, and this one, it's here. And you can come into this one. So you see this sync trigger, change analysis, and logs, all this key information. But we don't need to know this, but I'm giving you extra information. So if you get into this log file, you can see that application, and inside this function, and here's the function, and you can see this log file. Let's download it for the moment. I will say download. Click here to begin the download. Let it come. So now you understood why it creates the storage account. So the two important things to understand is inside the file share you'll have this function, and if you go into that function, that's the folder or the artifact where you will have this data, logs, and site. And site is a place where you will have this diagnostics, deployments, and it will tell that how many times the deployment and what tools were used and all the other things. But for now, we will focus only on the www root. That's the main folder where it hosts the host.json, and all our Azure functions will be in this place. So for any reason you need to do an investigation, what happened, then that's the place you need to go. And coming back to this application insights, you will have many things to cover. This itself will take a couple of days to discuss what it is, so at least we can do a transaction search. And I mean, it definitely takes some time. We might not be able to see any logs. Okay, good, we are seeing that. So it says that we sent 6 requests, and inside that 6 requests you can get into this application insights, and inside this it will give you many information. I mean, I'm just giving you only the tip of the iceberg, but in fact you guys will get a wealth of knowledge in this place. So if a function calls function B and it calls function C and all that things, you can come and track that. What is the input which you have sent, and what was the message? It will give you complete information. Okay. So it says that including what is the computer name on which it's executing. Even though we are telling that it's a serverless computing, that means we are not maintaining anything, but still there are servers where it executes, and this is the name of the computer where this function has executed just now. We saw that www root folder where we had the site, and that site has to be hosted somewhere, and this is the computer name of the computer where it has been hosted, right? So let's go back and do something different. Instead of doing the hello world, let's do something new. I'll come into this one. So let me go to this code and test. I think Nandip sir has already covered the previous things, testing it. So I'm doing a little different. I don't want to do the same thing. It will be repeated. So just trying to do something new. Okay, I might get hit with some roadblocks, but let's see. Hoping that I might not be hit with any roadblocks. So let's go ahead and start doing something. There's a lot of, this is one of the demo which I have given in Azure conference, this cloud conference, Azure Global Cloud Conference. I've given this. So it contains a lot. So let's see how much we can go and hit that. Okay. So let's start with that. So slowly we'll create these functions. So the first thing is what we have to do here is that we can try this one, the context.logs, and we can try that what all the things which we have at this point of time here. So let's see, try to change this little bit. Let's come back to this functions, and what I will do is I will remove every piece of code and just start with these things, whatever we need it. Slowly, simple function. It's not too much, but a very small function. So this is the body which we are going to return, and let's write down everything. We need a load dash also. Okay. So are we doing anything with the load dash at this point of time? We are not doing anything with the load dash. So what I will do is, for the time being, I will call this as a const body, and I will send in an empty let's send a response message. Okay, let's send the response message status, and let's do like this. Let's do some hard coding. Okay, it's not that a big deal. For that, I'll pass this couple of messages. That's it. Simple messages will initially pass this, and we are telling it's going to return the status as 200. It's a very simple thing. What it is expecting is it is expecting us we send the name in the body, and also we send digits. So the name we are already sending. So let's use the digits. It needs an array 1, 2, 4. So let me go and verify. Is that the exact thing which I sent it? Yes, 1, 2, 3, 4. Those are the couple of digits which we are sending it. So let me come and see that it has saved it perfectly. So now let's go and try hitting it with this postman. So it says that success is true, and it is giving us the response also. So somewhere are we logging the digits? No, we are not logging the digits. Now what will happen is, if we want to do something else, so load dash is one of the package npm. So here we are using one of the package we are using in this program is this lodash. So come back to this npm and check this. This has got a lot of facilities to work with array. So instead of we going and writing those utilities, we can go and do a straight lift from this and start using this one. So I used a couple of methods from this Lodash only. So it's a simple method. I am using this one. So for having an external dependency, how do you do that? Okay, we need to do that external dependency. So now what we need to do is we need to come back over here and get into this array operations, and need to go to the Kudu console. Hold on, I'm sorry. I need to go to the console, or I'll go to this Kudu console. There are multiple ways we can do. We can come to this console over here. So here also we can go and do that npm packages and all those things, or we can go to this Kudu console, which is pretty much an advanced version. And somewhere we will be having app service editor preview. So this is also we can go and work here, so that this shows all those content which we had it just now. So we can take us here and it will show those files. So we can start creating from here, or see that it directly took it to that www root, where we can see that what is the array functions. You can see all those things. We can create it from here, or we can try getting into this console. It's equivalent, and we can try it over here. So I feel very comfortable doing that from the console instead of that Visual GUI tool. So I do a dir. So now I have array operations. Mostly you can, if you know this Unix commands, you can use this. And let me do a clear. So now npm init. So I'm just trying to initialize that. Sometimes it doesn't work. That's a different story here. Let's go to this Kudu console. That's where it perfectly works, because we can try that here also. We can create a new file here, like package.json. We can create the package.json and add the packages over here. But I would like to do it from this command shell. We might need to switch between back and forth couple times. So we know that here you can get into this site and www root, and inside this array operations you can see that it is happening over here. So I'll do see that npm init. We are initializing this. Okay, so name is array operations. I'm fine with that name, and version is also I'm fine. Description I don't need to give. This I don't need to give, and author I don't need to give. I'm fine with that. Okay, so once that is done, what we need is we need the Lodash package. So for Lodash package, we need to execute npm I Lodash. So copy that command and come and paste it over here. Oh geez. So we can type it. npm I Lodash. So when we do this npm I Lodash, so you can see that it has created this, and it has created the node modules folder. So we can get into this node module folder. It is installing right now. It's not yet done. It is trying to do. So visually, if you want to see that, you can come in here and you can see the package.json. It has beautifully updated. You see that a lot of things it created, and it has also created the package log.json. So it has locked down that version. It says that to execute this program, it has got a dependency on this Lodash, and all the child dependencies also it is bringing in. So now we have the Lodash dependencies also done. Now we can quickly come back to the function app, and we can completely paste this entire piece of code. So I'll go into this code inside the function, Azure function, and you can see now, you can see this. You are having the package JSON, package log, index, and Azure function. Even you want to do some quick POC without having to know about the knowledge of the tools, CLI and other things, you can still very well use this entire portal to do that. So if you see that the process env computer name, I just wanted to show you what does that mean is, if you come here, I executed that over here. I said that process.env and the computer name. So that shows my name, that like this is my computer. And when we executed, it has shown it will show the computer name as little different. So let's see that when we go and hit this, it will execute that. So see this, it is showing that executed at DW0 HR0 2221-2. So that's a computer name. So you can see this when I execute this process.env on my local, it shows that it's Vishwanath Swami's computer. But when we execute it, the Azure function which has been hosted in Azure, it shows the computer name as it shows this computer name as this one. Okay, what if I don't pass this digits and click on that? So it clearly says that please pass name and data. Okay, that's the spelling mistake I forgot in my previous demo. So I'm signing in. Okay, here please pass that and digits. Please pass the name and digits. So let me save that and re-execute it. So if I come and re-execute it again, so it because I'm sending both, it is showing this. Now I will send only name. So it says that please pass name and digits. Both the inputs are required. So if I don't pass the name, again still we'll get the 400 bad requests. So for the function to execute, we need two parameters. We are passing this two parameters. One of the key thing what we want to know here is we see the Lodash, how we can use the external dependencies. So we have seen that there's something known as Kudu console. You can do it here also very well, but I'm not that much comfortable. Maybe I don't know how to use this. I am not sure, but I am very comfortable in this Lodash, where in this Kudu console, where I can go and execute this. One difference, one more thing what you can observe here is if I minimize this and expand this, so what will happen is if you see this Azure AZ portal AZ func .scm, you will not find the .scm. So if you see the difference between the hosted environment and the Kudu console will have .scm prefix in between the fully qualified domain name. Inside the FQDN, if you have SCM, that means you are inside the Kudu console. If the SCM doesn't exist, so that means you are in the hosted environment. So that gives very much all the details. So I really love this place a lot, because here is the way, here you will find a lot of diagnostic logs. So here you can see this log files, and here you will have the application logs. So you can come and check this logs over here. So it shows that all the operations, so you can see this, all the logging, whatever we do it here. So you can come and see this. Suppose if it is throwing some exception, you will very well can come and see that what kind of exceptions it is throwing, and how can you investigate it further. So that's one important place. And other thing is you have this Kudu console, and rest is this data files. So we have this sample data, and we have this secrets. So a lot of these two things. The same thing which we have seen in the same things which we have seen in this storage account for this resource group. So we can get in here, and we can get in here, and we can get into this storage explorer. And inside the storage explorer, we have seen that the file share is very critical and important, and please do not allow anyone to have access to this. If they go and do something, it might impact your solution. So please be aware. So you see this, previously it has got only two files, the function.json as well as index, but now we did lot. Now you're seeing this, even the node modules, that now that we know that, so whatever the function which you are executing, that physically exists somewhere. And this is one of the location which we can see that all the code which we are executing physically exists here, and all the logging and the secrets and everything is there in this location. But this is pretty critical, guys, so ensure that your storage is safe and it's not going into wrong hands, and they might do some mischief, and it might impact your execution. Chalo, okay. And I am 4 minutes crossed my time, and if you guys have some more time, I can go ahead with one more example, or if you're running short of time, then I can end my demo. So one quick point is like all the students will have free subscription, so you guys can go and have your free subscription and try this.
Thank you so much. Consider it a great privilege to have you all here as signatories. Now let's begin with second session, that is panel discussion over the topic Future Opportunities in Cloud Computing. Now I would like to welcome Dr. Manju Gupta ma'am, Ms. Niloshima Srivastav ma'am, Mr. Nindadeep Nachan sir. Sorry, the speakers of the event are Dr. Manju Gupta ma'am, Ms. Niloshima Srivastava ma'am, Mr. Nandadeep Nachan sir, Ms. Smita Nachan ma'am, Mr. Vishwanath Swami sir, and Mr. Bhaskar Das sir. Now I would like to introduce Ms. Smita Nachan ma'am. She has spoken at various C-Sharp Corner events. She is currently working as lead software engineer SharePoint at Tito Ivry. She is a Microsoft MVP, Office Development, MCT, author, speaker, organizer, and CSM. Now I would like to welcome Ms. Smita Nachan ma'am. Welcome, ma'am.
Hello all.
Hello, Smita.
Yeah, hope you're enjoying and getting some good information from all the sessions. And now we are here for all the discussions. So please let us know what type of questions you have in your mind after going through all knowledgeable sessions.
Now students can ask their queries to any of the dignitaries.
Good evening, everyone. My name is Aisha Awasthi, and my question for today is, in the last 3 sessions, we understood the various advantages that cloud computing offers to businesses and other institutions. But apart from it, what are the limitations of cloud computing when it comes to business firms?
Yeah, means at least one kind of an limitation. I will say is not exactly limitation, but at least so let's say means you will have to choose wisely the resources that you will need to use. The Azure as well as any of the serverless or at least any of the cloud provider gives you all the flexibilities by which you can choose, like do you want to create your solutions as a infrastructure as a service, platform as a service, or even the software as a service. There are no limitations as such, I will say, but for example, if you are more into the platform kind of a thing, but still you choose maybe the infrastructure or the platform, in that case, you will have to manage all of your platform upgrades and all those things. So I will say there are no limitations as such, but choose the right service at right point. Otherwise, you will face the challenges, and then those can become your limitations.
Thank you, sir.
Yeah,
I would like to add in this point. Thank you, Nandeep and Ayush. I would like to add a couple of points on your question. Is cloud is actually not the limitation; it's an opportunity. And with respect to, in fact, I see that limitation is. One must have to know that entire skill set about the cloud. So, a skill is definitely required. Either it is on-prem or the cloud. But you have to wisely choose, you have to see whether you are really required that cloud service or not. If you have a small company or organization or project and you really don't want to set up everything from the cloud, then definitely you can, have your own small infrastructure and on-prem. And that can be easy to maintain it, that's just, for the different opportunity for the different people. and cloud is actually getting more and more in this era.
Also, you can consider this security risk of this public cloud.
Hey everyone, my name is Manya Singh and my question is from cloud computing. What are the security laws which are implemented to secure data in a cloud?
So whenever we create any kind of an resources inside Microsoft Azure, we create we choose the location to which where we want to host that particular resource. So let's say, for example, if you choose to host that particular resource in central US or north US or maybe in Europe region, so all their local laws will be applicable for your data. So for example, if you don't want your data to be go outside of your territory, in that case, choose your region, and then all of the security laws, or I will not say entirely security laws, but at least the laws or the data laws which are for that particular region will be applicable for your resource. And again, from the security perspective, Microsoft do take care of all of your security of data through Defender, as well as safe links, safe attachments, all those kind of things are taken care by Microsoft. But this is one thing that we need to consider whenever we are creating any kind of a resource inside Microsoft Azure, the location where we are trying to create that resource.
Yeah, in order to that, there are certain security frameworks, security paradigms which are available. You can implement network segmentation. Your cloud provider gives you, right, if you are running multi-tenant network, you would want to access what segment in, whether it is on the right place or not, right customers are accessing it or not. And to do that, you can leverage identity and access management, maybe privilege access management, where you can implement your policies. You can enforce least privilege to restrict access. In short, there are basically 7 best practices which one can implement on their services. Two I have just mentioned: network segmentation, identity and access management, and PAM, privilege access management. Along with that, you can discover and onboard cloud instance and assets. You can monitor the user activity. You can have the password control, vulnerability management. You can patch and maintain your server, where your cloud insurer vendor is basically will ensure that they had a reliable approach to patch known vulnerabilities which you have in your machine. You can leverage encryption. You can leverage alerts and reporting. You like Mandeep rightly put, that there is a whole disaster recovery management running behind just to save your data. You have to be aware of what data you are backing up, what is the retention policies, the recovery policies, and of course monitoring. You have to ensure that you are doing, you are continually monitoring your environment and instances.
Good evening, everyone. I'm Devanshu, and my question is for Niloshima ma'am. And my question is, ma'am, as you said that we do not have to manage all the server, then external person will manage all the servers. So is our data secure if the external person is accessing and managing all the data?
Server management and data management are 2 different paradigms. And your servers will be managed by Azure. And they have this capability, what type of agreement you are in. If you are an organization, let's say you are an organization which is a banking domain organization, you don't want your data to be accessed by anyone apart. The customers are very vigilant for that data, and there are certain compliances also in place, compliances like GDPR, compliances like PCI DSS in payment industry. So there you can leverage, you can basically create your own data management plan. You can come up with a plan where you say that you can implement pseudonymization, you can implement anonymization, you can have your data on your own premises. And even when these cloud providers, they have your data, they do not go and check access that data. They just manage it for you. You don't, by management, what I mean is that, Devanshu, that they don't have to, you don't have to create backup every 24 hours. That backup, that retention policy, that disaster recovery will be implemented by them. Does that answer your question?
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
Good afternoon, everyone. I am Atul and my question is for Manju, ma'am. Ma'am, can you explain what are the different models for deployment in cloud computing according to you?
So I think there are four main models. One is public, private, hybrid, and community model clouds. So additionally, there are also distributed clouds that are not as widespread, such as multi-clouds, polyclouds, and other models. But before going into the depth of these types of these models, I would really like to tell you that what exactly these deployment models are. So what a cloud deployment model is exactly? A cloud deployment model is exactly a specific configuration of environment parameters such as accessibility and proprietorship of the deployment, infrastructure and storage size. And this means that the deployment type vary depending on how you control the infrastructure and where it is located. But if I define the private or public clouds, so public cloud, basically the name specify itself that these clouds are available to the general public and data are created and stored on third-party servers. Generally, server infrastructure belongs to service provider that manage it and administrate pool resources. So which is why there is no need for user companies to buy and maintain their own hardwares. So provider company offer resources as service both free of charge or on pay per user basis via the internet. So user can scale resources as required. So generally nowadays we are working on the public clouds, but as ma'am said, some of the particular domain, if we talk as the banking sector, so they may have their own private clouds. But then the advantage of public clouds are very, very in depth. See, it is giving you the hassle-free infrastructure management. It is high scalable, reduced cost, and 24/7 uptime. So this is one of the biggest advantage of public cloud. But there are disadvantages also, like compromised reliability, which is one of the biggest disadvantage. How can I say that it has a compromised reliability? Because the same server network is also meant to ensure engaged failure, but often it happens that public cloud experience outage and malfunctions, as in case of I think you must be aware of 2016 CRM Salesforce disruption that caused a storage collapse. So such kind of disadvantage are there in place of cloud, public cloud. Data security and privacy issues also give rise to the biggest concern, the lack of best focus services. So these are some of the disadvantages. But if I discuss about private cloud, so private cloud is different from a public cloud in terms of technical point of view, as their architectures are almost similar. So there is no architectural difference between private and public. But as opposed to a public cloud, that is advantage to a general public, only one specific company owns a private cloud. That is why it is called as a internal or corporate models, right? But if I talk about this benefits of the private clouds, so it give a very flexible deployment and high scalability because it is private to one company, which allow company to customize their own infrastructure in accordance with their requirement. They have high security, privacy, and reliability. So again, it depends upon the requirement and work structure. But there is a very biggest drawback of a private cloud is that it is very, very costly, as it requires considerable expenses as hardware, software, and staff trainings. So such kind of expenses add on into the infrastructure. So it shoot up the cost of this model. But if we talk about community model, so it is generally resemble the private one. The only difference is set of users. Whereas only in one company own the private cloud server, but in case of community cloud, several organizations with similar background share the infrastructure. You understand my point? I'm saying that several company with this similar background share the same infrastructure and related resources of a community cloud. Okay. So this is, I'm sure you must be understanding now because the benefit of this, community cloud, it has reduced cost, security, safety, privacy, and reliability is very, very much improved, and data sharing and collaboration is very easy in case of the community cloud. And the fourth one is hybrid cloud. Again, being an IT student, you must be very, much comfortable with this term, hybrid cloud, which encompasses the best feature of the, deployment model, public, private, and community. So it allows company to mix and match the models of 3 types based on the best suited of the requirement of the company. Right?
Thank you, ma'am.
Also have one query. My query is for Mr. Nandadeep Nachan, sir. So, what security parameters have been?
Oh, so sorry, I wasn't able to hear that clearly. Can you please repeat?
Yeah. What type of security parameters does cloud have in place?
Yeah, at least for the security parameters, firstly that we have a defender, because once it comes to the security part of it, the attack can happen by multiple places. It could be through an email, or it could be from any of the file, or even it could be from any of the user who is not having the access but directly want to get into the environment. So first thing that Microsoft has given there is the Defender things. So we do have Azure Defender, by which we'll be able to get all those security postures, as well as Azure has now given the or provided one more product called as Azure Sentinel. So at least with this Azure Sentinel, at least it help you to get the not only just detect all those kind of risk, but also mitigate all those kind of risk. So it can detect all those kind of potential attacks that might happen, and then give you the options by which you will be able to resolve those. So it can create the incidents on your behalf, and from there the action can be taken to resolve those kind of incidents. So at least these are kind of new security measures taken care by Microsoft to secure your entire cloud, as well as the even cloud, say Azure, as well as the Microsoft 365 environments.
Good afternoon, everyone. My name is Abhyuday Vats, and my question is for Vishwanathan sir. Sir, what exactly is a system integrator in cloud computing? Okay, I would like to pass this question to Nandadeep sir.
Yeah, at least once it comes to the cloud computing, we have various things, maybe the data storage, even your all of the data centers, your computing systems. So the major taken care by them is like, let's say, for example, if you just want to create your data storage, in that case also you have various options ranging from IaaS, PaaS, SaaS that we had discussed. So even, for example, if you want to create your own SQL server, we have various options. Firstly, that probably you can create a VM inside which you can,
wind up.
Okay, so you can have a VM. Sorry. So even you can have a VM. Inside that VM, you can install SQL Server. Even directly, you can have the Azure SQL instance in which you want to port your local SQL servers to the cloud, or even, for example, if you just want to have the SQL instance running into the cloud. So similarly, this one was just one example for data. Let's say, for example, if you want to have any kind of an edge server for your computing, even again there we do have various options ranging in the range of infrastructure as a service, cloud as a software as a service, even the platform as a service. So to all of the things, even including hardware virtualization, service oriented architecture, even the computing front, we have those options, including in the range of platform as a service, infrastructure as a service, and a software as a service. So we can look out to the best option which is suited for us and then utilize that. I hope that clears your question.
Yes, sir. Thank you.
Thank you.
Thank you, sir. Thanks to all the dignitaries and respected teachers for taking out time from the busy schedule and enlightening us with your great knowledge. Now, I would like to invite Dr. Preeti Bala ma'am for a vote of thanks. Oh, ma'am.
Thank you, Sakshi. Thank you so much. Thank you, everyone. On behalf of IMS Noida, I, Dr. Preeti Bala, and entire fraternity of the Institute, first of all, my sincere thanks to Almighty God for making today's event a grand success. I, Dr. Preeti, give a really heartfelt vote of thanks to our keynote speakers, Ms. Niloshima Shrivastava, Mr. Nandeep Nachan, Mr. Vishwanath Swami, Ms. Ismita Nachan, and Mr. Bhaskar Das, who spend their busiest time gracing the occasion. Your thoughts have enlightened our minds and shown us a new path. You have enlightened us about the cloud computing, and we really enjoy this session. I would like to give my vote of thanks Mr. Rajiv Gupta, President IMS Noida, our Dean Academics, Dr. Manju Gupta, our faculty members, students for their continuous support and love. Thank you so much, everyone, to be present here and enlightened us for such a good and really nice topic, which is related to the cloud computing. I hope I'm just giving my special thanks to Sakshi and Atul, who has just give their splendid performance during the entire event. Thank you so much.
Thank you, ma'am.
Thank you, ma'am.
Okay.
Thank you, Atul. Thank you all.
Thanks all for attending. Thank you for having
Thank you,
us.
sir. Thank
Thank
you.
you,
Thank
sir.
you,
Thank
everyone.
This was
Thank you, Manju ma'am.
Thank you, sir.
Thank you, ma'am. Thank you, sir.
Thank you so much, guys, for having us.
Thank you.
It's been a pleasure.